All right, let's get started. Hope everybody had a good weekend. The semester is giving us like this sensation that it's almost over, but it's not almost over. And this is the one thing I don't like about the fall semesters, that we get real close to Thanksgiving and people start, just, man, here comes the turkey, here comes the cold weather, here comes the football and all that. And they forget that they register for a 16-week class. So we are still, let's see, what's today? The 10th? 1, 2, 3, 4, 5, 6, 7, 8. We still have 8 more classes. Right?
Stop before the final?
I'm sorry?
Stop before the final.
And then we have the final after that. So we have 8 class meetings, and that's a lot of material still. So just try not to get too complacent, or else you're just going to get rolled over by Chapter 8. All right? All right, so I handed out something to you today. This is a really nice summary of a lot of the things that we're going to be doing in the next few sections. And for those of you who are going to go on and do some more math or engineering or anything that series might pop up again, this is a good reference page to keep handy. Because it brings together all the different techniques that we have for attacking a series and trying to figure out whether or not it converges or diverges. So what I'll start with today is what we ended class with last time. And that's the first test that is on this sheet. So the way this is laid out, it gives you the name of the test, the Nth Term Test, and then, what is it used for? Well, it's used when you're looking at some series like this. What does the test say? Well, it says that if the limit as n goes to infinity of a sub n does not equal 0, then what happens? The series diverges. And then there's a comment section on the side that says, if the limit as n goes to infinity of the sequence is 0, what? It's an inconclusive test, which means you don't know anything about what happens. So what makes this Nth term test nice is that all it involves is looking at the sequence, right? That's all you have to look at is the sequence itself. You don't have to look at them, each one added up, or the whole thing added up forever. You're just focusing all your attention on just the sequence and taking that limit. If it turns out to be something other than 0, you're in business. So let me give you a quick example of something like this. How about find whether or not this converges or diverges. Sum n equals 1 to infinity of 4n squared plus 1 over 3n squared plus 4. So is this anything that we talked about last class? Because we did talk about 2 types of series last class. Do you all remember what they were? Geometric and harmonic, right? Those were the 2. And these actually appear, let's see, harmonic is not on here, is it? No, hold on. Actually, it is. It's the P series, but we need to talk about that still. But geometric series is on here, isn't it? And this whole summary of how the geometric series works is here. So is this a geometric series? What do we look for geometric? What do we want the n to be in the exponent, don't we? And it's not happening. So this is not geometric. Is it harmonic? So what did we look for harmonic? Constant over a linear expression, right? That's what we're looking for. This is not a constant over a linear expression, so this is not harmonic. So if it's not the 2 things we've looked at, then it's got to be something else, right? So we're going to try this nth term test first. Let's take the sequence here, a sub n, and let's apply the nth term test to it. So I'm going to do, so watch, I'm going to write this out the way that I would do it if I were doing this problem. I would say to whoever's looking at my work, I would say here, nth term test. All right, I'm going to write that out so that everyone knows that's what I'm about to apply. And that means I'm going to take the limit as n goes to infinity of 4n squared plus 1 over 3n squared plus 4. And we know that that's infinity over infinity. So we can apply L'Hopital's rule, right? Now we're supposed to switch n over to x and make it real values, right? But we get to a point where we all, I'm sorry, I'm kind of congested, where we all understand that we can go to L'Hopital, switch it to x, and then switch back, right? So without loss of generality, that's what we like to say sometimes, we are just going to apply L'Hopital's rule to that. So we're kind of breaking the law here a little bit. But I think we could all agree that we could easily get to x and then back. So we get what, 8n over 6n? Agreed? The n's would cancel, and you no longer have a problem, right? This is just 4/3. So that number is not 0. And because it's not 0, the nth term test tells us what? The series diverges, right? So I'm going to state here, since this is not 0, my conclusion, I'm going to very, very explicitly tell you what the conclusion is. Therefore, the series diverges, and I'm done. So the work that I would look for on a problem like this, on a test, would be that you clearly state what test it is you're doing, and clearly show, this is where you're showing right here, is where you're showing that your test actually gave you a result that you can work with, right? This is showing you divergence right there. And then state your conclusion. Make sense? The nth term test is something that you want to do every time you have a series that you can't tell right away what's happening. All right, it's kind of like the first test. In fact, I did all the homework for 8.3 this morning. So we're not even in 8.3 yet, but I was doing all the homework for 8.3, and I got to a problem I was having some trouble with it, and it was the nth term test. It was the first thing I should have done. I even got used to just trying something else that I forgot about this test. So, yes? Always remember it's here? Okay. All right. So we'll use that when we can. Now, we're going to move on to another type of series now. So let's go now and talk about what's called a telescopic. Or sometimes referred to as a collapsing series. Now, I'll tell you where the name comes from after we do one, all right? Because it'll make more sense after I actually do the problem. So take a look at this series. I want to know if this converges or diverges. So I'm going to put C/D for this problem. Is that all right for everyone? So I don't have to write converge or diverge. So converge or diverge. Sum n equals 1 to infinity of 1 over n plus 3 minus 1 over n. So what do you think? When you look at that, is there anything that you notice or see or What do you see? You see harmonic, don't you? Everyone see that we have a constant over linear? And then constant over linear again? And we know that a constant over a linear, that's divergent, right? It's harmonic. Here's the problem, though. We're subtracting these two, right? And so you might think, OK, sure, I should be able to, don't write this down. You might think, oh, OK, I can just split this into two, like that, and say, oh, well, that diverges, and therefore it all diverges. Or they both diverge, so the whole thing diverges, right? That's what you might be thinking. But you can't. And there's the properties of sums are on page 441. I'm not going to write them out on the board because it takes too long. But one of the properties says is that the only time you can take a sum like this and split it into two, the only time you can do that is if they both converge. So if this converges and this converges, then you are allowed to do it. But if either one of them diverge, you cannot split it. You have to leave it like this. Understand? Yes or no? Yes? OK. So we're stuck, right? That's not going to work. So now, since we're kind of stuck, let's take a look at, let's just write some of these things out, right? How about we do that? Like, what is this? This is plug in 1. What do we get? So 1 over 1 plus 3 is 4. So we get 1/4 minus 1, and then plus. Now we move on to 2, right? Plug in 2, we get what? 1/5 minus 1/2 plus what? Keep going. 1/6 minus 1/3 plus 1/7 minus 1/4, right? Plus, I keep going, right? When do I actually stop? I never actually stop, right? It keeps going forever. Does anybody see something in there? What cancels out? This 1/4 here and this 1/4 would cancel, wouldn't they? They're opposite in sign, 1/4 and then minus 1/4. You'll see that? And then this 1/5 cancels out with this negative 1/5 here. How about this 1/6? I would have to go more further out, but it's out here, isn't it? And a 1/7, it's out there somewhere. And the 1/8 is out there somewhere. Do y'all kind of see things are starting to cancel out? All right? So here's what we're going to do. We're noticing some cancellation in there. That's the key. It's the first thing you need to recognize a collapsing series. You have to see some cancellation happening. Then we're going to go back to, look in your notes, the definition of what we meant for a series to converge. So go back to your notes. In your notes, it said something like, we say a series converges if S sub n goes to L. See, if you go back in your notes, you'll see this somewhere. If S sub n goes to L. And this S sub n right here was what we called the nth partial sum. So maybe it'll ring a bell if I say it this way. If I just go out on this sum, right? This goes from 1 to infinity. If I just say, look, just take the first one and add them up, you get an answer, right? Yes? If I say now just go from 1 to 2, you would take the first 2 and add those up and get an answer. If you take the first 3, you get those together and you get an answer, right? We said that those answers created a sequence. And that sequence that we created was what we called S1, S2, S3. It was a sequence of sums. And what we're looking for is for the sequence of sums to go to a number. And so that's what we meant by this. All right? OK, just follow along right now and see if you can handle this. What I'm going to do is this. I'm going to figure out what the nth partial sum is of this. And then I'm going to let n go to infinity. When I do that, I'll be trying to figure out if it goes somewhere. I need a little more room, so let's see what I can do. Let me rewrite the series up here, so that way I can refer back to it. Here was the series. And we already know that we get cancellation, right? Yeah? So now I'm going to write down what S sub n is. S sub n is what I get when I start adding these up and stop at n. All right, when I stop at n. So we already said the first thing I would get was 1/4. Notice I'm writing very small because I'm going to go pretty far, okay? I'm going to go 1/4 minus 1 plus the next one was 1/5 minus 1/2 plus the next one was 1/6 minus 1/3 and then plus 1/7 minus 1/4. Do one more, plus 1/8 minus 1/5 plus, right? Dot, 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 dot means it keeps going, right? But I'm going to stop it. And I'm going to stop it where? At n. So what's the last one over here look like? 1 over n plus 3, and then minus 1 over n. Agreed? So this is what happens if I stop at n, right? Stopping at n. What does the one before this look like? It's what I get when I take, instead of plugging n in, I plug in what? n minus 1, 1 less than it? So what would happen if I go to this expression, I replace this n and this n with n minus 1 instead? 1 over n plus 2 minus 1 over n minus 1, right? And I'm going to keep going back until I see cancellation. So you notice over here, when I did this, I noticed that I had the cancellation with the 1/4 there. I actually don't want to write over those yet. But do you see I had a 1/4 here and a negative 1/4 here? I had a 1/5 here and a negative 1/5 here. So I know I'm getting some cancellation. Yes? I want to come from the back side this way and see where that cancellation occurs. So do I have cancellation yet? Like, do any of these cancel? None of these are identical, are they? So I need to go back another one. So this time I'm going to be plugging in, what? n minus 2. What happens when I plug in n minus 2? 1 over n plus 1 minus 1 over n minus 2. Do I have any cancellation here yet? Any of these the same? These aren't the same, though. No. All right. So let me go back one more. I think I'm going to get it on this one. What am I plugging in this time? 1 over n and minus 1 over n, what? Minus 3. And I hope that comes out on camera okay. Can you all see it? You sure? Everyone understand there's dot, dot, dots in between here? I just am out of room? Yes? All right, so now what we're going to do is we're going to try and pick up on the pattern of cancellation that we have. Pay attention to the way I say this, okay? I want you to notice that the first number in the first parenthesis is killed off by the second number in the parenthesis, how many away? 1, 2, I'll say 3 away, right? So, or you could say 1, 2, 3. In the fourth parenthesis, right, the second guy is killed off by the first guy over here, right? Now, I'm going to stick to the way I like to say it. The first guy in the first parenthesis is killed off by the second guy in the parenthesis 3 away. Let's see if that pattern holds again. Is the first guy in this parenthesis killed off by the second guy 3 away? So if I go 3 parentheses away, 1, 2, 3, the second one should kill that one off, right? So first, guys, are killed off by second guys, but I've got to go 3 to the right, yes? So this first guy, is he going to be killed off? Yes, because there is something in that dot, 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 right, that will kill him off. The next first guy is 1/7. Is he killed off? Yes, because there's something in that dot, 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 3 away, that will kill him off, yeah? How about the 1/8? Same thing. That somewhere in there, it's going to start to look like a cluster, you know what I'm saying? It's going to be a mess. But all of those things circled are gone, aren't they? All right, let's talk about the second guys, because I haven't talked about the -1, the -1/2, the -1/3. I haven't talked about that yet, have I? But they are second guys, aren't they? Second guys are killed off by first guys, aren't they? But what, 3 ahead, right? So this -1, for it to get killed off, I would need to have something before it, which I don't have, do I? So he stays. I'm going to put arrows on everything that stays. That guy's still there. This guy right here, does he get killed off? No, because there's not something 3 away. So he's still there. On the next problem, there'll be she's, right, just to keep it cool in here. All right? This problem, these are all he's. All right. This stays, right? There's nothing 3 ahead. But from here on, they were gone, aren't they? All the second ones are gone? All right, let's talk about the tail end of this sum. First guys get killed off by second guys 3 away. So this guy should get killed off if there's something 3 away. 1, 2, 3. There it is, right? So this guy right here gets killed off by this right here. They're gone. All right. How about this first guy? Doesn't go anywhere. Because you would need something 2 away, right? And I stopped at n. Right? I stopped at n. So there is nothing to kill off this one 3 down. So that stays. Let's get these arrows out of here. Those are confusing now. How about this first guy? Nothing down there, stays. This first guy? Nothing down there, stays. What about the second guy here? The second guy has to be killed off by something 3 in front. Do I have something 3 in front of this one? Somewhere in there, right? Somewhere in the dot, dot, dot. This one gets killed off. Somewhere in here. This second guy, same thing. This guy gets killed off by something in there. This one right here, killed off by something in there. And the last one, well, we already took care of the last one, didn't we? So the arrows, those arrows, are all that remains, right? That's all that remains. So would you say that we have some stuff in the front that stayed and some stuff in the back that stayed, but everything in the middle canceled? What were these called? What types of series? Collapsing. Imagine a bridge going across, and you imagine the bridge collapsing, right? Everything in the middle falls out. You got the ends still standing. That's kind of the idea. The series collapses in the middle, and you're just left with stuff at the ends. Telescopic, old school telescopes, you know what I'm talking about? You look through it, you collapse it down, right? And you wind up with the 2 ends coming together. That's the idea behind the language of this. So S sub n is equal to whatever was left. 1/4 plus a 5th. No, shit, those were gone, sorry. -1 minus a half minus a third, those 3. And then down here, -1 over n minus 2 minus, Jesus, Robert. No. What's happened is, what I'm used to doing when I do these is I actually cancel these out so I don't mess them up. Like I actually come in here and cancel them like that. I was using circles so you could still see the numbers and not get too crazy, but this is a little easier for me to see what's left. This one's left, right? And then this one's left. And finally, this one. So this is a sequence, isn't it? This is a sequence. S sub n. What's that? No, this is a sequence of numbers, isn't it? If I plug in 1, I get an answer. If I plug in 2, I get an answer. If I plug in 3, I get an answer. The question, and each of those answers represents me going further out in this sum, right? As I make n bigger, it pushes this side out, doesn't it? Makes this sum longer. And what I want to know is what happens as n goes to infinity now. So all you have to do is take the limit of this as n goes to infinity, and that's the answer. So what is the limit as n goes to infinity of S sub n? So look at this right here and tell me what happens as n goes to infinity. It's just the first 3 numbers. -1, -1/2, -1/3. Right? Because this goes to 0, this goes to 0, this goes to 0. And let's figure out what that is. Get a common denominator. How about 6? So -6/6 minus 3/6 minus 2/6, which is -11/6? -11/6. That's right. This is what the series converges to. If you were to go out and start adding these things up, right? If you were to do 1/4 minus 1, 1/5 minus 1/2, 1/6 minus 1/3, and you were to go forever, if you could go forever, if you could, you would get closer and closer and closer to -11/6. That's what it converges to. But the setup of the problem is the most important thing. You first recognize you have cancellation from the very beginning. Then you write out S sub n. And this is the part that everyone messes up on the test. They don't do S sub n. They do take a limit, but they don't write it down properly, and I take off for that. You have to write down S sub n and write down what that partial sum is. Then, once you figure out what the partial sum is with the cancellation, then you take the limit and you get an answer. I'm going to do one more of these, all right? The setup's going to be exactly the same. We're going to look at the series. We're going to try and find cancellation. We're going to write the partial sum. We're going to figure out what happens with the collapsing. We're going to take the limit, and that'll be our answer. All right? What does a harmonic series do? Diverges. Geometric series converges if the absolute value of r is less than 1. Diverges if the absolute value of r is greater than or equal to 1, right? So you're telling me that if I give you a geometric series with the absolute value of r less than 1, you can tell me what it adds up to be, right? It's a over 1 minus r. There's a formula for the answer. So a geometric series is a series we can actually find the sum of, right? A telescopic is another type that you can find the sum of. Like we can actually find what the number is if it converges. The reason why I'm bringing this up is because on a test, I like to give problems where I say find the sum. Okay? I say find the sum of this series. That's different than asking if it converges or diverges, right? I'm telling you there is a sum. And that, to you, should set off a little alarm that says, wait, he's telling me to find the sum, which means that it must add up to something, which means it's got to be geometric or telescopic. It narrows everything down for you. That kind of makes sense or not? Okay. Let's do another one. What's that?
This one never
You can have this diverge. Just like geometric series, it can. But if you're ever asked to find a sum in this class, it's either going to be geometric or telescopic. It's going to be one or the other. Let me see here. Sum n equals 2 to infinity of -3 over n squared minus 1. Instructions here, find the sum. So I'm hinting to you that it does add up to be something. In your homework, when you get to these problems, it says here, these are problems number 25, 26, 27, 28. It says, determine if the series is convergent or divergent by expressing it as a telescopic sum. So they're telling you within the homework problem that it's a telescopic series. I won't do that on a test. I'll just tell you, like, find sum. And then you kind of have to know what that means. What's that? Good. So what now? N plus 1. So you want to do the nth term test? Just to start, to make sure this doesn't, like, it's not easy? You want to do that real quick? Nth term? What's the limit as n goes to infinity of negative 3 over n squared minus 1? It's 0. What does that tell us? It doesn't tell me anything. So that failed. But that's okay. At least I know it wasn't easy right off the bat, right? All right. So is it geometric? No, because n's not in the exponent. Is it harmonic? It's a constant over a quadratic. That's not a harmonic, right? So maybe what you would do next is you would say, all right, let me write out some of these to see if I can get some cancellation, right? That's what you might think. So let's just see what happens if I start plugging things in here. What if I plug in 1? Oh, notice I'm starting at 2. Why am I starting at 2, not 1? Because 1 would give me division by 0. So I started it at 2. No big deal. So 2, if I plug in 2, I get negative 3 over 3. So it would be negative 1 plus, what's the next one? Negative 3 over 8 plus negative 3 over 15 plus negative 3 over 24 plus dot, 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 right? Can anybody tell me why you should be concerned? Nothing's canceling, right? I mean, do y'all see that? Nothing is canceling here? I mean, we would, at the minimum, we would need at least some of these to be positive, wouldn't we? They're all negative. So your instinct here would be like, well then, I don't know, maybe it's not telescopic, right? Right? I mean, it kind of looks like, how could it possibly be telescopic? So I heard something to factor the denominator, because it's a difference of squares. We could do this, right? We could do that. And if we start plugging numbers in now, it's not going to change anything. We're still going to get this same result. Nothing is going to cancel. But what's that mean? What do we call that? Splitting it. I don't know. We did it. There was an entire section on this with integration. It was the last section of integration. Yes, we call that partial fraction. Partial fractions. We should be able to split this up into 2 different pieces. So I'm going to stop for a second. I'm going to do a real quick partial fractions here. Did you just say ridiculous? Oh. Oh. I thought you said this is ridiculous. So the way we did this, we said we had 2 distinct linear factors, right? Distinct linear factors. So I put a over n plus 1 and then b over n minus 1, right? Something like that. And then I figure out what a and b are, right? So I have to do my little thing. We've done this a lot, I hope. Then you could say, hey, look, let's kill off b. Let's let n be negative 1. And then when you do that, Thought I made this where it was going to work out nice. Oh, shit. Okay, if n is -1, what do we get? -3 equals a times what? -2. Sorry, I was trying to avoid fractions. I must have messed something up when I was putting the problem together. 3/2 is a? That's a. All right, what's b? So let n be what? Let n be 2? No, let n be 1, right? That's going to give you -3 equals 2b. So -3/2 is b. Is that okay? We all right with that? All right. So here's the way I can rewrite this series. I'm going to come back up here and rewrite it. It's going to be rewritten as, in parentheses, a over n plus 1. So 3/2 over n plus 1 plus b, which is -3/2 over n minus 1. Y'all still there? Everyone still there? Got it? And I can start working with that right there. Now I'm going to change it a little bit because I noticed that both numerators have 3/2. And I'm going to factor 3/2 out, and I'm going to pull it out of the sum. So I'm actually going to have this. 3/2 comes out of the sum. N equals 2 to infinity. And then what's left in here is 1 over n plus 1 minus 1 over n minus 1. And so what I did when I pulled the 3/2 out of this, I was left with a -1 there. And I just changed that to a minus and made that a positive 1. Do y'all have any questions? Sure? Let's write out what this would be equal to. 3/2 out in front, right? And then here's our sum. Let's plug 1 in first. What do we get? We plug in 1. 1/2. Sorry, you plug in 2. Thank you. We were about to have division by 0, weren't we? Plug in 2. We get 1/3, right? Minus 1. Now plug in 3. We get 1/4 minus 1/2. Keep going. 1/5 minus 1/3. Oh, you see it? There's going to be a canceling right there. And then 1/6 plus minus 1/4. There's another canceling, isn't it? Yes? And that keeps going forever. So I've recognized I'm going to get cancellation. And since I've recognized that I'm going to get cancellation, I now need to do what? S sub n. We need to figure out what S sub n is. What is the partial sum? So I'll write it down. So notice that what I'm doing here is I'm kind of stopping. I'm saying, okay, I've got a pattern. I've got it to get canceling terms. So I need to figure out what the partial sum is. The partial sum will be equal to 3/2. So I'm carrying that with me. And then let's write out this partial sum. This is where I'm going to have to write real small. The first piece of the partial sum is this. So I'm just going to repeat this, right? The only difference is I'm going to have to add a tail piece onto this. So 1/3 minus 1 plus 1/4 minus 1/2 plus 1/5 minus 1/3 plus 1/6 minus 1/4 plus, I think that'll be enough. I get 2 cancellations in there, don't I? I have 2 of them right there. So that should be enough for me to pick up the pattern, hopefully. And then plus, let's get the tail piece. So I have a bracket down here. I already know I'm going to probably have to have 3 of these to see the pattern. Yeah, it's good enough. What's the last one? Plug in n, so you get 1 over n plus 1 minus 1 over n minus 1, right? The one before that is going to be just take 1 away from each of these. So 1 over n minus, what? 1 over n minus 2. The one before that, 1 over n minus 1 minus 1 over n minus 3. Do you want to go one more? I have space for it. I have space. You're out. 1 over n minus 2 minus 1 over n minus 4. Now look, the pattern in this one I think is exactly the same as the last one, but it's not always that pattern. All right? You might have, if you get lucky, you might have the first one here canceling with the second one here. They might be right next to each other. They might be 2 down, might be 3 down. I'm not going to go past 4 down. Okay, I won't be that mean to you.
You can kind of tell how far down you have to go by the plus 1 and minus 1.
That's right, the distance between those two numbers. Yep. Oh yeah, it's not 3 down in this one, right? It's only 2 down. So let's start canceling. And this time I'm not going to circle. I'm going to just cancel them because it confused me last time. This 1/3 cancels with this one right here. So the first girl cancels with the second girl 2 down, right?
No, you sure?
See, it works better with guy?
Yeah.
Okay, we'll do guy then, if there are no objections. All right. All right, so look, here we go. First guy cancels with second guy 2 down. First guy going to cancel? Yeah, because there's going to be a second guy 2 down somewhere in there. First guy here? Gone? Somewhere in there. Second guys require something in front, so this second guy stays. I'm actually going to circle the ones I want to keep this time. Sorry if that confused you. Those 2 stay, don't they? Now, back here, first guy cancels with second guy 2 down. First guy, does this first guy cancel? First guy cancels with second guy 2 down. This first guy? Stays, right? He does not have anything 2 down. This first guy? Stays. How about the second guys here? Second guy requires first guy 2 in front, somewhere in there. Second guy requires first guy 2 in front, somewhere in there. This one's gone. Okay, so I think I've got everything, right? It has collapsed on me. So S sub n is equal to whatever's left. -1 minus 1/2 plus 1 over n plus 1 over n plus 1. Let n go to infinity now, right? It's -3/2. Yeah. So now we take the limit as n goes to infinity of S sub n, which equals -1 minus 1/2, which is -3/2. This converges. The series converges to this. All right? Is there a problem? Y'all are all looking at me like I'm crazy. Why what?
What about the 3 halves?
Oh, the 3 halves in front. That's what you're talking about. Yeah, I forgot about it. So this,
You just gotta put a square on.
look, this right here, I'm glad y'all said something because it would have been wrong. I need 3 halves in front of that, right? This 3 halves right there. And then that puts some 3 halves here. I'm going to tack it onto the back of this, which means What's our answer? We're multiplying, right? Right? Negative 9/4. Sorry about that. What's wrong, everyone? Only if there's a number that goes into both of those. You're trying to take square root of both, maybe? No? What do y'all think? Telescopic. Kind of weird, huh? So I'm going to give you a hint on a problem like this. If someone were to give you natural log of n over n plus 1. Try nth term first. If you do nth term, you get infinity over infinity here. You could do L'Hopital on that, and that would give you a 1. And natural log of 1 is 0. So the nth term would tell you nothing. So you'd start to try and figure out what's going on. It's not geometric. It's not harmonic. How could that possibly be collapsing? That's right. You can split it into 2 logs, can't you? I don't know if that's what you were going to say, but if you have log of division, you can split it into 2 logs with subtraction, can't you? And now you could start writing each of those out, and you would start to get collapsing at some point. And I can almost guarantee you on that one will diverge. Because when you get to the very end, you're going to have some stuff stuck at the end, some stuff at the beginning. The stuff at the end is going to have natural log of n in it. And when you let n go to infinity, natural log of infinity goes to infinity. So that's going to diverge. But there's one like that in your homework. Actually, that one is in your homework. It's number 26. So I did that, I'm sure, on the video. All right. That's it for telescopic, okay? So we're starting to get a bucket of series that we can deal with now. We've got geometric, harmonic, telescopic, right? Geometric, harmonic, and telescopic. The next type of series that we're going to discuss are what are called P-series. And this is on your sheet. All P-series look like this. The P stands for power, okay? And so what you notice is that with the P-series, the n is not in the exponent, so it's not geometric, right? It's not a geometric series. You have 1 over n to a power. And this series might converge, it might diverge. It depends on P, and that's all it depends on. And I'm not going to go through the proof of why this is true just because of time restrictions. But I think you'll agree with me. We already know what happens if P is 1, right? If P is 1, this is harmonic? Yes? So I know that P is 1, it's going to diverge. Well, it turns out that if P is less than or equal to 1, it will diverge. And it turns out if P is greater than 1, it converges. And we're just going to accept that and be okay with it and move on with our lives. This is on your sheet, okay? It's on here. But I'm just stating it up here so we see it. So let's take a quick look at an example of a P-series. Here we go. Some examples here. Converge or diverge? Question. Sum n equals 1 to infinity of 1 over n squared root n. So you start running through your table of ideas. Is it geometric? Is it harmonic? No. Is it telescopic? Probably not, because if it was telescopic, I would have to be able to break it into two pieces, right? So I could get some subtraction in there. Doesn't look like it's telescopic. Oh, Nth Term Test. What would happen if we did Nth Term Test? That would go to 0, which doesn't tell us anything. So really, we're kind of running out of options here. So is it a p-series? I could rewrite that as 1 over n to what power? It's n squared times n to the half, isn't it? That's what that means? So you add the exponents, 2 plus a half, 5 halves. This is n to the 5 halves. And that is a p-series, isn't it? P-series with p being, p is 5 halves, which is greater than 1, isn't it? So the power is greater than 1, and therefore what? It converges. Therefore, it converges. All right? We don't know.
Would that answer suffice?
Because I'm asking if you converge or diverge. If that's what I'm asking, that's all you have to answer. And like I said in the very beginning of this, for where we're headed, convergence or divergence is all we really want. Okay? We don't care what it goes to. If there's anyone who is having some trouble with their grade at the end of the semester, I'm going to offer, it's going to be about a 1.5 hour lecture over Fourier transforms. And if you come and you attend that, you get bonus in the class for attending the lecture. And I will show you how difficult it is to get some of these series to actually find their sums. But that there are ways to do it. But they're just really complicated. Probably after the final. Yeah. I'll let you know later. Yeah. On campus somewhere. Yeah. No. Yeah, we're just going to, yeah. I'll let my wife know my Cal 2 class is coming over. Just making sure there's nothing else. Oh, how about this? I have a question for you here as another example. Sum n equals 900 to infinity of 1 over, well, let's make it negative 11 over n cubed. What do you think? Think it's a convergent p-series? Yeah? Does the fact that it's negative 11 up there bother you at all? No. Okay. Because you could probably just take that negative 11 out, right? Right. Is that okay if I do that? Yeah? And this is a p-series? P being 3, which is bigger than 1, so it should converge. So if this converges to a number that I multiply by negative 11, it's still a number, right? But there's something else. It's not bothering anyone? The sum is starting at 900. Do you think that that's going to matter? No. What does the formula say? It says p-series looks like this. N equals 1 to infinity of 1 over n to the p, right?
It needs to be starting at 1?
That's what I'm asking you. What do you think? Does it need to start at 1 for me to be able to say converge?
It gets to 900 at some point.
This right here, right? This right here is actually the sum n equals 1 to what? 899 of 1 over n to the p plus sum n equals 900 to infinity of 1 over n to the p. Would you agree with that? And if I know that this adds up, converges to a number, and it's equal to these two sums, then these two have to be finite numbers, right? There's only one way I can add a number to a number and get a number is if they're both numbers, right? Like whatever this number is. So it's like what you're doing, this piece right here, right, is just that piece. So it's actually smaller than the whole sum would be, wouldn't it be? So it's got to still converge. Does it work with divergence? What do you think about that? So let me change the problem. Let me make it this. Negative 11 over n. Does that change your answer? Or are you still going to say diverge? Still diverge? This is a more profound question. Converge? Let me see if there's a way I can show this graphically to see if it makes sense with a picture. I'm going to draw two situations. Let me tell you that if I take this bucket, I guess, and I stack up 1 through the infinity layers of, I'm pouring stuff in here, and I'm going to have 1 layer, 2 layer, 3 layers, and I'm telling you that if I put an infinite number of layers in here, it converges to a number, right? Then if I just stack up, if I ask you to just look at 900 and up, that has to be a number also, right? It still has to converge. If the whole thing is a number, then just part of it should also be a number, yeah? But what if I tell you this? I have bucket, and I stack in this layer of something, and when I stack the layers, it actually overfills the bucket, right? It's going to overfill. So this diverges. Understand? Then if I ask you to look only from 900 outward, can you say that that has to diverge? What can you tell me about this? This is a number, right? This is finite, which means the rest of it has to be infinite, right? So there's a theorem in the book that says, or there's a property that says that a finite number of terms of a sequence has no effect on its convergence or divergence. So if I take out the first 899 pieces, it has no impact on whether or not it converges or diverges. What I can't do is take off the tail end that goes to infinity. Now that would change things. So this would still diverge, which means the whole thing diverges. All right? All right, that's more of just an FYI. I don't think that comes up in the homework. All right, we doing all right? We've got 40 minutes still. I'm just making sure. I think I'm done with 8.2. Yep, that's 8.2. That material up to that point will guarantee be on your test on Tuesday. Right?
The test has to be on Tuesday?
Pardon me?
The test has to be on Tuesday?
You want to move it to this Thursday again?
No. Thursday?
Next Thursday? Then you're going to have all of 8.3 on it. Let's see how today goes, like the rest of today and maybe tomorrow. I mean Thursday. My plan is to do the test on Tuesday.
Are you going to give a bonus? Like the problems, like we do them and then they come in and
I hadn't thought about it. I'm not sure. Hadn't really even considered it.
I got so many points on that. 0.5.
Really?
All right, so if you look down our handout, the nth term test we've got, the geometric series, we kind of know what those look like. We just talked about p-series. The next two things on our sheet are the integral and comparison tests. So I'm going to go